Hello and welcome back to the Geomorphology video series provided by the Purdue University Kids STEM program. My name is Wimbo. In the last video, we had a brief review on the history of geomorphology. Today, let's introduce the stage where landscape evolution occurs, our home, Earth. The surface of the Earth has many important components for the life form we have today. A solid rock ground for us to stand on, an atmosphere composed of gases that we breathe in, and different forms of water that we drink. All those components belong to dynamic systems that are generally phrased as cycles. Among them, there are two cycles that are most closely related to the landscape evolution: the water cycle and the rock cycle. In addition, our body, as well as other life forms of animals and plants, are composed of chemical elements. These chemical elements also interact with the water cycle and rock cycle through life and death, creating a unique biogeochemical cycle that also plays a role in geomorphology. Let's start with the water cycle. We know that 71% of Earth's surface is covered by water. The surface and near surface waters of the Earth is called the hydrosphere. The water cycle describes the circulation of water between the hydrosphere, the atmosphere, and the near-surface rock ground. Probably the most famous form of water cycle is the water circulation between land and ocean. Water in the ocean evaporates to form water vapor in the atmosphere. The water vapor is transported to the land by wind. Along the way, it is precipitated as rain or snow if it's cold. Rain that falls to land has three common paths. In the first path, the water flows on the land surface, also known as runoff. The water runoff connects and forms the surface drainage system. As water flows from high ground to low ground, it generally ends up being in a lake and later evaporates into the atmosphere again, or back to the ocean. In the second path, the water infiltrates soil and rock and goes to the subsurface, becoming groundwater. The groundwater has its own subsurface drainage system. Although slow, the subsurface drainage will also eventually lead most water back to the ocean. The rest of the water might go into deep storage or go back to surface to recharge soil water storage. In the third path, the water can be stored in soil and absorbed by plants. About 97% of plants absorbed water will evaporate through leaves, stems, and flowers into the atmosphere. Such a process is known as transpiration. Although less common, water can be absorbed by rocks and sediments in the form of hydrous minerals or in pore space. During subduction events in which surface rocks and sediments move to deep interior of the Earth, the water they carry will be removed from the water cycle. Eventually, this water will ascend back to surface, commonly through the medium of volcanoes and mounts. As the volcanoes release its water back to the water cycle, it also brings deep earth materials into the surface rock cycle. The rock cycle is the repeated creation and destruction of Earth's surface rocks. Melts erupted by volcanoes will cool down and form new rocks. This cool video records such process. Any rock formed from the cooling and solidification of molten materials are categorized as igneous rock. Just like how new rocks will form, old rocks can be deformed. If a rock is buried underground at high pressure or heated up by hot fluid or subsurface heat, the rock will change its mineral composition and/or texture and become a different type of rock, like this rock in the picture. This transformation process is called metamorphism, and the product of metamorphism is called a metamorphic rock. In this picture, you're looking at a typical metamorphic rock. The stripe pattern you see on the rock are aligned minerals that are results of high pressure. During metamorphism, the rock does not melt, unlike igneous rock. The transformation of metamorphic rock is done as solid status. Beyond deformation, old rocks can also wear away. You probably have seen this scene of piles of rock fragments and sediments lying next to a rock cliff. This is part of the rock breaking down processes of weathering and erosion. If there is a river passing by this pile of fragments, the river will further remove these fragments and sediments from the pile and transport them downstream. As the river flow velocity reduces at flat area, these materials will be deposited at the location. This is a process called sedimentation. As more and more sediments are deposited, their weight will force them to be compacted. At some point, they might be cemented together into a piece of rock. This rock is a typical type of sedimentary rock, which is a category of rocks formed from the deposition of particles or precipitation of minerals from pre-existing rocks or organism remains. Many organisms will extract rock-related elements like carbon, oxygen, phosphor, sulfur, or nitrogen from the environment and secrete biogenic minerals as skeleton or exoskeleton. Biogenic means the mineral is produced by organisms. For example, coral reefs or shells are in many cases carbonates, which is a series of minerals containing carbon, oxygen, and other elements like calcium or magnesium. When generations of coral insects or shellfish die, the mineral remains gets accumulated through time. Eventually, they can form a piece of rock like in this picture. This photo shows a type of sedimentary rock called coquina. It's formed almost solely by the exoskeletal remains of shellfish and marine invertebrates. In addition, activities of plants and animals can directly lead to the weathering and erosion of rocks, as well as production of soil. Such a process is not just part of the rock cycle, but also a part of the biogeochemical cycle. To summarize, today we gave a brief introduction to the circulation in water cycle, rock cycle, and geochemical cycle. In the later videos, you will learn how these cycles together shape our landforms.